Hi guys, welcome to video lecture part 2 of mass movements, erosion, and glaciers. So this is where we left off. We talked about how places with little vegetation, not a lot of plants, trees, or grass are very susceptible or can have their soil eroded really quickly, as well as places with little water or moisture. We talked about how the water weighs down the soil, making it harder to move. So places like our beaches and deserts often experience a lot of wind erosion. Here's how the wind moves the sand. So wind causes the sand to jump and bounce. This is called saltination. Hard word, but it's what happens. Grains of sand only rise above the surface about 1 meter, even with the strongest of wind. Some of the effects of wind erosion that we see, one of them is deflation. So the wind removes topsoil, which lowers the land and leaves rock fragments that are too large to be lifted. This is really common in deserts, and this is actually how the Dust Bowl happened, or what happened in the Dust Bowl. So the Dust Bowl happened, and we're going to study this when we study the human impacts, but the Dust Bowl happened because farmers weren't planting cover crops or leaving the crops on their fields after they harvested them. So what it looked like is a bunch of empty fields with just open dirt, and we learned that that's not good because that dirt particles, because they're tilled up and they're not compact, they're really easy for the wind to move around, and in fact they did, and that's what caused the Dust Bowl. After the Dust Bowl happened, though, the wind carried up all that good topsoil that was great for growing, and all that was left was really compacted, rocky, stony land, not good for growing at all. So the Dust Bowl was devastating in the fact that it killed a lot of people, and it damaged a lot of property, but also it took us years to get our topsoil back to where it needed to be. The other effect of wind erosion is abrasion. We talked about abrasion when we discussed weathering, but abrasion is rocks being hit by something or hitting something. So in this case, we're talking about rocks getting worn down and smoothed by blowing sand, like what happens in the Grand Canyon. This is what happens, or how we get that soil to be lowered and lowered. So you can see we've got 1, 2, 3, 4 rocks on top right here. So for the most part, this would be nice sandy soil, or nicely loose soil right here with just a couple of rocks. But deflation happens because the sand or the soil particles are moved and displaced, and then it gets a little bit lower. We start to erode a lot of those sediments off, and then we have quite a few rocks here. And then it happens again until eventually we get to the point where it's only rocks on the surface. And that's not good for growing things, nor is it good aesthetically. Here's some effects of wind erosion. Dunes are a very first effect, or another effect we've already talked about too. So these are sand dunes. They can look like desert dunes, or they can look like the dunes that we see at the beach. Dunes form because that sand that was eroded and moved away ends up somewhere. It's dropped or deposited by the wind and causes dunes to form. Dunes are basically mounds of sand, and they're formed by the wind. They're common in deserts, on beaches, and on the shores of really large lakes. So one of the common things why you can't play on the dunes or walk up in the dunes right here, because they're protective structures for the houses and people right here. In Lake Michigan, near where I grew up, you could walk on the dunes, and the fun thing or the activity to do was to snowboard down the dunes or sled down the dunes. Very fun. So here's how this happens. We get our wind picks up those particles, and then once the particles hit something else, they stop moving, or if they just lose momentum. If enough of them accumulate in one area, we're going to get a dune. So the purpose of these fences bamboozled me when I first saw the beach. That makes no sense. They're not keeping anything in or out. You can go around them. These fences are structures that help build our dunes. So the wind is either coming in this direction or this direction, and what the fences do, they act as a barrier which stops the wind that's blowing the sand. When the sand hits the fence, it drops down there. Eventually, we're going to get dunes that look more like this, that has almost buried the fence in sand, and that's how we build some of our dunes. Other ways we build dunes are called sea oats. They're plants, and they help build dunes as well. But again, dunes are protective structures for property and property, houses, land, people, whatever is in between, or whatever is threatened by the ocean waves. Now, dunes on a normal day where the sea is just fine and we've got normal tidal processes, dunes aren't super important, but when we have events like hurricanes, dunes are really important at protecting the property and people that lie beyond the dunes. That's why we don't walk on them. True or false, the process by which the products of weathering are transported is called erosion. This is true. The movement of rock fragments down an incline as a result of the earthquakes is mass movement. This is true. True or false, landslide is the sudden movement of loose rock and soil down a slope. This is true. And we're not doing soil samples, so ignore that. And then your last bit of notes, these are all about glaciers. We're studying glaciers because with mass movement, because glaciers often carry sediment and lots of it from one place to another. What are glaciers? Glaciers are very large moving masses of ice. A glacier is what punctured the hull of the Titanic and made it go down. We have glaciers towards our North Pole region and our South Pole region. They form near the Earth's poles and in the mountains at the highest of elevations. And typically they are found in areas where more snow falls than melts. The snow in these areas is compacted and recrystallized into ice. And an example of this is making a snowball. So when you make a snowball, and I don't know how you have a snowball fight, but I make my snowballs to hit my sister with the most force possible. That meant that I found my snow and I put it into a ball-shaped form, and then I took off my gloves and I used my hands to warm up the area, the snowball a little bit, get it a little icy, and then I put my gloves back on and I let it freeze a little bit, and then I threw it. So it was more like throwing a semi-ice ball at my sister instead of just a snowball, because when you throw a snowball, you really wanted to make it hurt. So that would be an example of them, but on a much, much smaller scale. The world's glaciers cover about 10% of the Earth's surface. Did you know that? If all land ice melts, oceans will rise 230 feet. So when we talked about climate change, one of the things we discussed was how our ice glaciers in our icy regions of the world are melting, and how that could lead to a possible sea level rise. But that is not, we have not rose sea level wise 230 feet, nowhere near that yet. But one of the thoughts is, what if it does? In the last ice age, which is right here, the glaciers covered 30% of the world. The ice age ended about 10,000 years ago, though. As you know, naturally, we're experiencing a much warmer climate than what happened in the ice age, which is, and we look through the geological time scale, that is natural and normal for us to go through periods of really cold and really warm. There are two types of glaciers. We have valley glaciers and continental glaciers. Let's look at those. So here's an example of a valley glacier, and I think they are beautiful. Valley glaciers form in valleys and mountainous areas. They flow down the valley like a thick liquid. Think like a slushy. These glaciers will carve and widen a valley. So as this snowy, slushy mixture moves down this valley of the mountain, they're picking up the sediments with it, or some of them. Think about like taking ice and scraping it against a rock. While some of that ice is, yes, going to chip away, some of those rock particles, especially if the rock is soft enough, will break off or weather as well. And then because ice is an erosion method, ice might also pull with it those sediments and move it from one place to another. Continental glaciers, they're also called ice sheets. They cover a continent-sized area. They form in the really, really cold polar regions like Antarctica and Greenland. So these, while these are much smaller and more slushy-like, this is more ice-like, and just think complete land covered in ice. this is just a little portion of the land. When we talk about glaciers, we talk about them advancing and retreating, and this is referring to their size. So when we say that they're advancing, they're growing. When we say they're retreating, they're shrinking. Modern day glaciers are shrinking or retreating as an impact of global warming. So as our world warms up because of the greenhouse gases that are in our atmosphere, and because of the excess greenhouse gases in our atmosphere, our glaciers are shrinking because they can't stay cold. It's getting too warm for them. One of the things we talked about with our glaciers shrinking, or as ice shrinks and melts, we're raising the albedo or decreasing the albedo of our area. We're creating more green and brown spaces, meaning that we're heating up the earth even more. But again, that's climate change, and that's not what we're talking about right here. So let's look at icebergs and glaciers. So icebergs come from a glacier in a process called calving. The iceberg will break from a continental glacier. So that's what happened here. And that's what they hit in the Titanic, was an iceberg, which was once part of a glacier. So calving is when they break off. Till and moraine, these are some structures that are left behind after glaciers melt. So as the glaciers move and melts, it leaves behind the sediments that it was carrying from one place to another. The sediments is called a till. If I get enough accumulation of sediment on the side of a glacier, like here's the glacier right here, the sediment that is on the sides is called a moraine. Not something that you might need to remember as far as knowing what till and moraine specifically are, but one of the main takeaways here is that our glaciers are moving mass amounts of sediment. We also have what we call kettle lakes and meltwater streams. I think this kettle lake is quite beautiful. I would love to go visit something like this. Since glaciers are ice, they leave behind a large amount of water as they melt. A kettle lake is formed when a large piece of ice breaks off and is left to melt. You can see the glacier is retreating right there. This is the kettle lake. It was once part of the glacier and then it melted. A meltwater stream is a stream that forms when a glacier is melted. Not quite as cool as the kettle lake. We also get glacier depressions. So these meltwater streams can carry some of the sediments that the glacier had in it. And when the meltwater streams dry up, like it did right here, we're left behind a bunch of sediments deposited in the land. This land is called an outwash plain. Remember, deposition is dropping, so the glacier drops, or the meltwater stream drops those sediments. And that is the end of our slides. Have a great day, guys. Make sure to turn in all your notes. If you have questions, please email me.